Here are the notes for density. This is N3 if you are following along in your packet. So we'll start by reviewing velocity because there are some parallels with the velocity equation we used last unit and the density equation that we will learn today. So let's say we were given this problem and we drive 100 miles to visit our grandparents and it takes 2 hours to get there. To calculate velocity, just remember it's displacement over time. So 100 miles over 2 hours is 50 miles per hour. The units here are miles per hour because we take miles divided by hours. If we were going to increase our velocity, we would want to see what happens to the amount of time it takes to go that same distance. So let's say we're going faster. To go 100 miles, it would take less time if we were going faster. If we traveled for 2 hours and we were going faster, what would happen to the distance that we travel? We would just go more than the 100 miles because our velocity is greater. So we'll see some parallels with density in a second. Density is defined as the amount of mass per unit volume in an object. So it's just basically how much stuff is there inside of any given volume of that substance. The units for volume that we'll use are any metric units for volume, so milliliters, cubic centimeters, or cubic meters. For mass, it could be grams, kilograms, or milligrams. The equation for density is just density equals mass divided by volume. And this comes in a couple different versions, kind of like velocity was displacement over time, and then we solved it for time and solved it for displacement. Here, we have the following three equations. So this is just density is mass divided by volume. Take a look at our units here. Capital D is density, lowercase m is mass, uppercase V is volume, not velocity from last unit. Then if we solve it for mass, mass is just equal to density times volume. If we solve it for volume, volume is equal to mass divided by density. So if we wanted to actually use these equations, here is how we would pick out which equation to use. So in this first problem, it's asking what is the density of a brick that has a mass of 2,500 grams and a volume of 980 cubic centimeters. So it's asking us to find the density. So we pick out our equation here that solves for density. So density equals mass divided by volume. So we just pick out that equation and we can substitute it in. Remember, we look at units to determine what is mass and what is volume. So grams is mass, cubic centimeters is volume. So we take that 2,500 grams divided by 980 cubic centimeters to get a density of 2.55 grams per cubic centimeter. To get units of density, we're just taking whatever the mass unit was over whatever the volume unit was. So if it was like kilograms per cubic meter, that's what we would use in our, or for our units instead. In the next one, we're asking what is the mass sample of methanol if the volume is 40 milliliters and the density is 0.719 grams per milliliter. So you can pause the video here and try and do this for a second, or try and do this for yourself. In this one, we are given the volume and the density, and we want to find the mass. So I'm going to use the version that has mass solved for. So it's just my density times my volume. So density times volume, I take my density, which is always mass over volume, some units here. So 0.719 times my volume of 40. I get that from the milliliters. And then I can solve this just by multiplying. So 0.719 times 40 is 28.76. To get units for this, we need to look at what are the units of mass that we were given in density. So we were given grams per milliliter. So if I multiply that by milliliters, the milliliters just cancels out and I'm left with grams. So my answer will be in grams. Here's the next one. Again, you can pause the video here and try and solve this on your own. In this one, we are asked to find the volume. So we pick out the volume version of the equation. Volume is mass divided by density. So we just need to pick out what is mass and what is density. Look at the units again. 2,300 grams, that's a mass. 0.8 grams per cubic centimeter, that's a density. So in this one, we just take volume is mass divided by density. 2,300 is our mass. 0.8 is our density. So 2,300 divided by 0.8 is 2,875. To get units for this one, we just take the volume part of density. So density was grams per cubic centimeter. We're looking for volume, so our volume is just going to be cubic centimeters here. So that's why it's just cubic centimeters. Density is a relationship. So objects have a mass and a volume. So if you look at any object that you can pick up, it has a mass you can measure, it has a volume you can measure. But different objects of the same substance, so let's say I had a small ice cube and a large ice cube, they could have different masses and volumes. So in our example here, we use a block of cement and a large block of cement. They can have different masses and different volumes just because they're different sizes. So here we look, mass is 300 grams and the volume is 100 cubic centimeters. The next one, larger mass, larger volume. What density does is it tells us for a substance. So both of these are made out of cement. Both of these will have the same density because of what they are made out of. So density does not matter on the size, the shape, anything like that of the substance. It just matters what the substance is. So if we were to calculate, the small block of cement has a density of 3 grams per cubic centimeter, as does the large block of cement. So even though the masses and volumes are different, since they are made out of the same substance, we get the same density. So density is a property of the material and not the actual object that you are looking at. So it depends on the material. If we look at differences in density, if we have more dense objects, they either have more stuff, so that means mass, in the same amount of space, or they have the same amount of stuff in less space. Whereas less dense objects, just the opposite is true. So they have less mass in the same amount of space, or they have the same amount of mass just in a larger volume. So if we look at these images here, this shows us on the left side an object with low density because it has very little substance in that space. And then all the way on the right, we have a very high density because it has a lot of stuff, a lot of mass in that same amount of space. And then in between, they just show increasing densities. So we go from low density over here to a slightly higher, higher, and then the highest density. So just as we pack more stuff into that space, we get a more dense object.